Hello, good afternoon. My name is Amy Dariana Atede Rodriguez of the IMEC 102 group, and I will talk you about abstract. Camargo is a new producing city. Thanks to this project, we generate benefits for the farmers who have and work the governments. The Technological University of Camargo was one of the most specialized careers for innovation, which deals with the career in mechatronics. With this project consisted of following of an existing project, innovating and improving the machine with the use of the technology, reducing costs and personal work. The company Agroindustrial San Luis gave us the opportunity to work with this project. This company manufactures agricultural machinery for the field. In addition, this company supports us economically and in service, lending us with place of work and the necessary machinery to work. For this project, it took us approximately 4 months working and interacting through some sessions. Since as a result of the pandemic, it was very difficult to get together.
Hi, my name is Edgar Reid, and I'm going to talk about the flow sensor or flow meter or liquid flow. Well, these sensors have some names, but these sensors are used for gauging mass flow, flow velocity, or a volumetric flow rate of a liquid. It can be calculated by determining the speed of a liquid over a particular area or as force created by a flowing stream over powers undefined compression. Well, this is the programming and the principal watch. For example, in the left in the image, you can see a mirror measurement with an A caudal where you can see the velocity that the liquid pass for the sensor. So you can see a volume, for example, in the tank or some recipient, uh, to the caudal for L, diagonal line, and the time in seconds. And this communicate is visa. For example, in the right image, you can see the block visa that you can communicate the Arduino, uh, and this problem for some serial port. This is the name serial port, and for example, if you connect the Arduino with a computer, this block Visa block show the port COM. For example, COM3, COM4, COM5. The velocity is 9600. Is the velocity of the Arduino. Uh, this communicate is about Visa. And other blocks can you see, for example, the blocks that color yellow are mathematical formulas and simple connection because you need a put for the Arduino signal need to need to be different because cannot be direct. So you need transform this signal of the Arduino and the sensor uh, with mathematical formulas can you see in this picture, and some blocks are for show you some date. Well, in this image is a programming an Arduino because there are some communicate different communicate between Arduino and LabVIEW. For example, Lifa. Lifa is easy when you use LabVIEW, but in this case I use other communicate. For example, uh, this these images show how I'm programming variables. For example, uh, some mathematical the principal mathematical formulas cause in the Arduino work more than the mathematical from the LabVIEW. For example, you can see variables, for example, volume equals 0, int pin sensor equal to, and other description. It all numbers that can you see in this image, for example, of 1, 2, 3, 4, 5, 6, 7, 8, have description about the work that the text. Well, this is all.
Good night, my name is Iram Delgado and I am going to talk about the measure of revolution per minute. And the company that designed the spraying machine ISCET used for an indicator of the impeller speed, and we use it a Hall sensor. And model is age 8 and 10 and 42 and magnet of neodymium, and the magnet is very strong, and which the signal is obtained um, through a whole type and sensor, and this sensor obtained the signal and of neodymium. That sensor registers the tones and by means of electric impulses. Um, in this way, we obtain pulses for each turn of the rope. Well, we count those pulses and the revolution per minute. Um, we do the coded in Arduino in the part of the revolution in we declare the variable count and the increment impulse on one and the data is printed and to send into W and through the serial import, and there in LabVIEW we show the revolution per minute and indicator, and that's it's all for me. Thank you.
Hi, good afternoon. My name is Daniel. Our project is an automatic sprinkler. Margo is a nut producing series. Thanks to the project, we generate benefit for the farmers who have and work the walnuts. The Technology University of Camargo has one of the most specialist careers for innovation, which the career in mechatronics. With this project consists of following up existing projects, innovating and improving the machine. With the use of technology, reducing costs and personal work. The company Agroindustrial San Luis have used the opportunity to work with the project. This company manufactures agricultural machines for the field. In addition, this company supports youth community and service, lending youth a wide place or work and the necessary material to work. And so, for this project, it took use approximately 4 months. Interact and working in the company workshop with the help of some teachers and company staff. The teamwork is a very important for the manufacture of this project, since collaboration is needs several tasks and hubs, in addition to having to responsibility to fulfill. And I'm going to show its parts we make of the machine. This is the chassis assembly of the powder and laces for trial with PTR 242. This is the impeller bracket, machine weights, plate and reinforced for supporting blades, and the aluminum impeller assembly to reduce weight. This is the aluminum impeller assembly to reduce weight and increase speed. This is the cannon sight with holes for express. And this is the layout, side barred front, and the sign sights in line C40. This is the assembly spray cannon. This is the layout, protective followed ward. This is the tank with capacity of the 1,875 liters. This is the ultrasonic sensor with a range of 8 meters distance and sensor base for AI-163. This assembled in the barrel and stored in the chassis bunker. Final design prototype. The sprinkler.